Today we're going to look at system of equations. What a system is, it's a group of equations, getting lazy and putting them all on one graph. And that's it. We're taking two lines, one graph, and then asking, where do those two lines meet, if they ever meet? So before we do that, let's look at our possible types of solutions that we can come up with. So this first graph here, I've got two lines. I have a green line, I have a blue line. Those two lines, they meet at exactly one spot. We say that we have one solution here, okay? They meet one spot, that's it, move on with life. Next, I have a green line and a blue line that seem to be parallel with each other. And we know parallel lines never end up meeting. They never cross, they never touch, none of that. These two lines, even though they're on the same graph, they are a system, but we do not have a solution. A solution is where they meet. We don't have any of those. So we end up saying no solution. Lastly, I see one line here, but I really have two lines. Those two lines happen to be right on top of each other. Since they're on top of each other, every single point that one line touches the other is a solution. Everywhere along this line, we have two lines on top of each other. Since they're always touching and they'll never stop touching, we end up saying many solutions, or sometimes you'll see infinite many solutions. So two lines, they hit one spot, one solution. Two lines, they're parallel, they never touch, no solutions. Two lines, one happens to be on the back of the other line, going everywhere the other one goes. Everywhere they go is a solution or many solutions. Okay, so that's just types of solutions. How do we even get there? Well, first off, we're going to have two different lines that we need to look at. The first one, y equals 3x plus 1. I need to keep in mind slope-intercept form, y equals mx plus b. I want to graph both of these individually on the graph. So first, with the top one, my y-intercept is 1. I find the y-axis, I find 1 on it, and I make a coordinate. From there, I need to move using a slope. The slope is the number in front of x, and I'm going to turn it to a fraction. Instead of just saying 3 as a slope, I'm going to say 3 over 1. So now I have that rise and the run. So here I'm going to rise 3 spots. So start, I'm going to go 1 step, 2 steps, 3 steps. I'm going to run 1. And I could even take this one more step up. I can go 1, 2, 3 over 1. And if we wanted to, we can also go in the reverse. Now, instead of going up and to the right, I can go down 1, 2, 3 and to the left. And we can see that all 4 of these coordinates still fall in line with each other. So let's connect. Sometimes I find it easier when you do more than one coordinate. It's easier just to connect the dots and you can get a straighter line that way. Okay, next one. Y equals x plus 3. So my y-intercept here is 3. That's where we're starting. 1, 2, 3. My slope is 1 over 1. 1 over 1, where am I getting that? I don't see a 1 anywhere. The x, it's just plain old x. We do have a number hiding in front of it. That number hiding in front is a 1. You can turn that 1 to a fraction by putting it over 1. Now you have a rise, you have a run, 1 over 1. So from that 3, I'm going to rise 1, I'm going to run 1. I'm going to go up 1 to the right 1. And look at that. That happens to be on one of our coordinates that we already have. Go up 1 to the right 1, up to the right. And we can do the same thing in the reverse. Go down and left, down and left. And now you got a whole bunch of dots. Can we connect all of them? I want to know exactly where do these two lines end up touching each other. Well, we end up meeting right there. We have one solution. What is that one solution? 1 1, 2, 3, 4, 1 comma 4. We always want to state what the solution is if we can state what the solution is. Okay. We're not always lucky with having questions or equations in slope-intercept form, y equals mx plus b. Sometimes it's in standard, and sometimes we have to do a little work to get it that way. So let's do this work to make both of these say y equals. So I'm going to let's start with the second one. I'm going to solve for y. Minus 3x minus 3x, 3y equals negative 3x and 12. Divide by 3, y equals negative 1x plus 4. That's one equation. We need that. Let's take the second one, or well, I guess the top one. X plus y equals 4. I need to get y alone. So y stays, x goes, minus x, y equals negative x plus 4. And now, why did I put the x first? Well, y equals mx plus b. I want to make sure the m and the x are always before the slope, or before the y-intercept. Here I have a number in front of x. Here I do not. I can put a number here, and I'm going to do that. I'm going to put a 1. I can turn both of these to fractions. So let's put it negative 1 over 1, negative 1 over 1. And let's graph. So I'm going to start with this bottom one here. My y-intercept is 4. So find the y-axis, find 4 on it. 1, 2, 3, 4. Plot our point. We want to move using our slope, negative 1 over 1. Go down 1 to the right 1, down 1 to the right, down and to the right. And you can also go in the reverse. Instead of down right, we can go up, left 1, up, left 1. Whole bunch of dots. Let's connect them. Okay. Let's go to this blue one now. So y equals negative 1x plus 4. Find 1, 2, 3, or 1, 2, 3, 4. We happen to share a point, and now our slope happens to be all of the same points. And when we connect them, I know this is really sloppy, but you can at least see the two lines. They're supposed to be in the same spot. Okay, well, if over here we just said, well, that one solution was 1, 4. What's the one solution here? Well, when you have two lines creating one line, I can't just name one answer, one coordinate. So instead, I'm just going to simplify it and just say many solutions. And that is your answer. That's how you solve graphing systems of equations.